Hello, welcome to MongoDB Podcast Live. I'm Shane McAllister. It's great to have you. And today we're diving into the fascinating intersection of robotics, machine learning, and real world applications with the true innovator. And to elaborate on the amazing title of Turning Chaos into Opportunity, please join me in welcoming Albert, the CEO of Lazy Dynamics, a company revolutionizing how systems react and adapt in dynamic environments. Albert, you're very welcome to the MongoDB podcast.
Hi, Shane. Yeah, thanks a lot for this introduction. Happy to be here.
Not at all. It's great to have you. Thank you for joining. I always start, and I know we did a prep call on this, I always start with our guests to tell us a little bit about their career path to date and how they got here. And in our conversation, Albert, that was incredibly interesting. So I know we don't have all the time in the world, but maybe perhaps give us a potted history of your background to date and how you ended up being the CEO of Lazy Dynamics.
Sure. Yeah, I'll try to compress it as much as possible. But my background, so basically I hail from a far east of Russia, a place very far from where I'm based right now, which is in the Netherlands. I completed my bachelor's degree in the western part of Russia, like at the St. Petersburg State University, where I was studying applied mathematics and control. So upon graduation of my bachelor's, I think I was a bit lucky to get a scholarship for a 2 years master program in Japan, in Kyoto, in computer science, where I dove into self-driving cars and driving aids research when it was hot. Well, it's still it's still hot, or like, let's say it's wavy, right? It's like always 5 years away. Back in 2016, it was quite hot. Was coming in 2 years, and yeah, so I embarked on that research where we were developing essentially an assistant for elderly drivers, so that could predict their intention to emergency brake before they even hit the braking pedal. Okay. And the research, I must say, like, progressed well. We even secured a patent, but when we tested it with real drivers, my friends, we hit quite a roadblock. So they basically hated the system. They really didn't like it, to put it mildly. And and the reason was that it generated too many false positives. So it was trained on the so-called average driver, right? And like, now it's retrospectively it seems obvious, but well, back in the days, like, it wasn't. So the problem with average driver, it doesn't exist. So and then it led me to explore like adaptive systems, adaptive technologies. How could we kind of leverage that prior knowledge from many drivers that we've researched, right? But then to fine tune itself in real time. So how can we kind of have a system that can fine tune itself in real time to the actual person behind the wheel? And I think this eventually led me or guided to my PhD, working on adaptive hearing aids. And it may seem that it's completely orthogonal problem, right? Like, where is like the self-driving cars, or like where is the hearing aid patients, right? And in a way, they are different problems, but what connects them, there is no average hearing aid patient. There is no average driver. And for both tasks, we actually require to have a system, or now as they call it, an agent that can adapt into the ever-changing world. The acoustic environment changes, right? The road changes. And then also there's kind of a sense of the personalization. Like, we want to personalize the hearing aid algorithm to basically work for a particular human driver, for a hearing aid patient. And that's basically what I've been working on during my PhD. After I think 4 years, we've basically developed the general toolbox, a solution, as we call it, an engine that enables this type of adaptive learning. About a year ago, we spun out from our laboratory, and I guess, everyone in my team, co-founding team, took nice roles, and like, I was assigned as a CEO, I would say. Well, so that's kind of how it worked out. Yeah.
I love that. Assigned as a CEO. So let's talk a little bit about that. I suppose maybe the team itself, the diverse academic background that the team has that you've assembled in Lazy Dynamics, and I suppose in the pathway of talking about that team, talk a bit about the driving force of the spin out from the university then as well, Albert.
Right, right. So I think kind of the core team consists of 5 PhDs. So each bringing critical expertise. Like we have our mathematics guy, our coding expert, an engineer, and
Mm-hmm.
of course the research lead. Then I guess there is me like serving as a CEO. So precisely because I'm not excellent at any of those other specialized roles. So yeah, but
I'm
I can
sure
help
you're very
bring.
much underestimating yourself there now,
Yeah,
Albert.
that's what they say. I think I'm definitely good at bringing it all together. So that's basically, I guess, a connection point for all of that. But the background is rather diverse, I would say. So we actually all came from different masters and a bachelor. So some people were like doing mathematics, some people were studying neuroscience, and then after all, it sort of started to converge into one solid idea
Mhm.
on creating this sort of engine or software toolbox that merges many different ideas to create, well, one solid framework to, well, to enable, as we call it like now, adaptive intelligence.
Okay, okay. So from a timeline point of view, that team, which, as you mentioned, a blend of maths and engineering and coders, etc., and the scientific knowledge behind it all, that was about a year or more ago, then was it, Albert?
Yeah, I think so. So we were incorporated 1.5 years ago, but we truly started to work, I think, like 2024. And the reason for that was simple. So like when we established the company, there were some of our co-founders were still doing PhDs. Like actually, like they were very close to the end, so it was not an option to do a dropout. So
Hmm.
which
Hmm.
normally founders do, but in our case, it was like, come on, just three
Yeah,
more
get through it.
3 more
Yeah.
months that of course extended to half a year, but nevertheless they finished now. So now we're all PhDs basically. Yeah.
Okay. Wow. Wow. So look, in your own case, a huge background there in variety, and as you said, there are similarities between the self-driving and the hearing aid. But tell us a little bit about what Lazy Dynamics then is focusing on.
Yeah, I think the best way actually to go about it is like to well to go a bit backwards actually, like so
Okay.
to start with a bit of well observation about this kind of founding story. So and the interesting observation is actually about these current AI systems.
Mhm.
So everyone is now talking about agents, about entities essentially that perceive their environment, take autonomous actions to achieve certain goals.
Mhm. Mhm.
And the problem we identified at Lazy Dynamics, and we kept identifying throughout our PhDs, is that most agentic systems that are based on, for instance, LLMs, which are fantastic technology with great implementation in content creation, outreach campaigns.
Mm.
However,
Mm.
when you try to build, let's say, agents for mission critical sectors, say autonomous systems, smart cities, finance, or hearing aids,
Okay.
the partners we are working with, they aren't eager to bet LLM-based agents that can hallucinate and struggle to adapt quickly enough. And this is kind of exactly what we provide with our engine. So agentic systems based on probabilistic modeling. I will not go into much details, just not to pollute this conversation, but they basically we try to make agents that adhere to rational reasoning and adapt rapidly to changing conditions. And just
Okay.
to give you
Mm.
a really tangible example, I think so. You can imagine, let's say, like an ambulance rush into a hospital.
Mm.
Yeah,
Okay.
and an agent which is inside this emergency car, right? So it needs to find the fastest route. So it needs to continuously like process real-time traffic data, weather conditions, emergency vehicle locations to dynamically update this optimal path.
Mhm.
Yeah.
Mhm.
So unlike the traditional navigation systems, our agent, it adapts its decisions based on the changing probabilities.
Okay.
So say you are in the junction and like now you can take left or right. And the system tells, okay, if you go left, it will be 6 minutes. If you go right, it will be 5 minutes. However, I am very uncertain about if you actually turn right. Yeah, these 5 minutes can actually turn to be 15 because there are like some conditions there. So
Okay.
the agent actually tries to proactively suggest alternative by considering this uncertainty around certain decisions that it's going to make. So yeah.
Okay. I think that's a good real world example, but I suppose how are you, what's the heart of the system there that you're building? You mentioned a toolbox earlier as well too. How does it, and I understand that example of an ambulance and there's a driver, hopefully in the ambulance, we haven't got to that stage yet where we don't have the
Yeah.
driver. But obviously you're looking towards, drones and driverless cars and other things that are making these decisions on their own, right? So the toolbox you're saying that Lazy Dynamics have built, how is that addressing that bigger problem?
Right. So the toolbox is called Infern, and it's basically an engine that allows to build agents. So
Okay.
what we do is essentially we provide tooling for users to uh, create agentic systems by using some Lego blocks, as we would
Okay.
like
Mhm.
adaptive Lego blocks that we call probability distributions, or like let's say functions that
Mm.
allow to essentially describe the environment where the agent lives, right? So be it
Okay.
if we are talking about the drone, we describe through some high-level abstraction functions. Okay, how's the dynamics of the drone changes? Like
Mhm.
say if I'm here at point XYZ and I want to go to XYZ T1, right? So how these dynamics work? And the thing is that some people they know these dynamics already, so they can just provide those. But
Mhm.
sometimes it's not really known. Like there are like some robotic system for which you might not have the full description of this of the internal dynamics or
Right.
of the model of the world. So we basically create these additional building blocks which also encapsulate the parameters of these unknown functions. And the idea here is that once the drone goes out in the world to solve a task, and the
Mhm.
task we can mean like surveillance, or we can think of going just from point A to point B, the drone needs to figure out, okay, what type of the actions or like controls it needs to apply in order to reach the goal.
Mm.
But
Mm.
first, it might have to, well, to learn a bit its dynamics, so it needs to do exploration. So essentially what we do is like what our SDK allows to create is, well, describe the model of the world for the agent
Mhm.
and then run the inference. So basically then you press the button once you've specified your agentic system, your goal. So once you run our SDK, it allows, it provides you with the solution, sort of a solver, how to reach that certain goal in the environment you've described.
Okay, fascinating. And I know we're going to see a demo of some of this later on towards the end of
Yeah.
our conversation. So for our viewers joining in now with Albert and me chatting away about what's very complex, you are going to get an illustration of how this works and what it entails as well too. And for anybody joining the live stream, if you've got any questions as we go through, you may not have seen the beginning where I was saying, and some people have shouted out, said who they are. Do let us know where you're joining in from as well too. But as we go through the conversation, if you have any questions in particular for Albert, please throw them in there. We'll either take them live or we'll look at them at the end as well too. So you mentioned, the toolbox and it's adaptive and it's learning, but let's step back a little bit. Obviously, agentic systems are super new for a lot of people. So how much of what you're doing today is also education, Albert? Like, are you, this is super new for a lot of companies and potential customers of yours to allow kind of agents run and manage what they need to do in this space. So how do you get across that level of education that's required? Or, does your demo do that for people, customers, and they have that wow moment? How does it work?
Yeah, that's a good question. So we've actually started off with approaching partners who are already aware of, well, the internal sort of the mechanics of what we are doing. So that
Mhm.
was pretty easy, and like it's usually like R&D departments, right? So they have like a couple of PhDs themselves. So,
Okay.
but you are right in
So
the
they
sense that
already have the pain point and they know how complex this is, and therefore quite happy to see how you can help.
yeah, absolutely. So that was the case, but of course, there is a lot of education going on from our side. So in fact, I mean, first of all, right, there is a whole space of this agentic AI, as they call, and like it's actually such a broad term, and like many
Mm,
people mean different things. There is a lot on, well, LLM side, like which I mean, transformers essentially just enable to compose this building blocks of different agentic systems, and now there are like different protocols, both from Anthropic and Google, and
mhm.
we are not in that market. I wouldn't say that we are in a like a sort of a competitor. We are rather a complementing side
Okay.
of that story, and
Mhm.
the complementation comes from the fact is that we are um, basically enabling or providing physics. We are like providing physics for this agentic system. So, right,
Okay.
as I said, like with the drone, we provide some physical properties. We kind of ground it in the probability theory, and we ground it in the physical world. So, in that way, of course, it's a newish approach, although it's been around for some time. We do have collaborations with some institutes, well, which is like Active Inference Institute in, I think they're based in States. So where we sometimes give some tutorials on how we
Mm,
can create these type of agentic systems, as well as actually our open source part of our venture, which is called RxInfer, right? So it's
mhm.
rxinfer.com, where is a lot educational material. So like starting from very basic stuff on probabilistic modeling, how to solve, how to figure out that the coin you are tossing is fair or not fair. So this type of things, and going all the way to how to build a drone. So it's really a granular, I think, approach to, well, to educate people on how to, yeah, utilize these systems and utilize these approaches to build this type of agentic systems. Yeah.
Okay. Okay. And so obviously we're on the MongoDB podcast. Where does MongoDB fit into the technology stack, Albert, that Lazy Dynamics have? How are you using MongoDB and its capabilities?
Yeah, I think, yeah, I have actually a bit of a story with MongoDB. So
Okay.
I first yeah I first encountered it during my bachelor's when I became interested in well, actually MapReduce algorithms. So I wanted
Mm,
to do, yeah, something back in the day simple with Twitter data. So like let's say finding popular hashtags or similar like analytics. And Twitter data, it includes really diverse content types, right, that evolve over time. And then I've stumbled upon MongoDB, which was essentially allowing storing this document-based structure, right? Like varied
mhm.
data types, rigid schema constraints, and yeah, this is why, yeah, I've just started to work with that, and interestingly enough, I think it's also a good lesson for me personally, is like why you should read documentation, because, well, somewhere along the lines of MongoDB docs, it was 2015, I actually think. So it was written that, guys, if you're trying to use this MapReduce for this particular problem, you are doing it wrong. Like there's like some aggregation functions that you can make use of. So like just don't use MapReduce for that. So yeah, so I've spent quite some time, like which were gone in vain. Well,
Mm,
and
mm.
at least I learned MongoDB, also learned a bit of Python because the course was in Python. So
Okay.
it was
Okay.
good. And then actually just 8 years later, yeah, 8 years later, I think. So when we started to work in our company, we realized that our engine, well, which was working fine in academic settings, but when you bring it to the industry, right, it requires many additional elements, right? Servers, backlogs, data safety
Mm,
measures.
mm.
So, and then, yeah, I was just like, okay, what's now out there? And then I came across MongoDB again as an interesting solution, perhaps because you can imagine like for drones is one type of data, but when you are
Mhm.
like doing finance or something else, it's a different type of data. So again, like rigid schema. And I pitched this idea to our CTO, Dmitry, and yeah, here we are. So basically, its flexibility and performance characteristics made it well ideal fit for our dynamic data needs.
Okay, excellent. So the yeah the I can understand why. Yeah, in the with the Lego blocks that you're offering and the different areas in which you can work, a rigid structure, rigid schema wouldn't work at all. And to me, it's interesting to see that pathway. You know, that kind of 8-year gap is because obviously in developer relations where I work, we're about enablement and awareness and planting the seed. But as I keep telling my VPs here, it's a long time potentially for that seed to grow. And in this instance, you had familiarity with it, and when the calling came, you went, well, I think MongoDB could be very suitable for this. What in particular, I mean, are you taking use of time series data? Are you using a MongoDB Atlas vector search and what we have there now? What parts of our ecosystem that you are using at the moment then, Albert?
Right. So I will go into the details of how we use it at the moment. We are indeed working with so we've started to work with this leverage in time series database because yeah, it's a critical dimension in our system, right? So basically MongoDB allows to improve our ability to process temporal data efficiently. And this is just, it's not just a technical optimization. I think it's fundamental to how our agents understand and respond to the world. And I must say that we haven't utilized this functionality fully yet. So
Okay.
it's still something we are working on, and like perhaps actually we will jump on it pretty soon. Um, as for vector search, yes. So, and this is something which is really cool in MongoDB. So, one of the pilot projects that we've been working on, it actually, well, it we had to work with a lot of textual data. So
Okay.
it's actually textual data spread in time also. So it's like you can imagine there's like some text that yeah we have at it 1 hour timestamps. So and then of course our agent to enable this sort of navigating through these documents, we did have to provide it to some vector searches like what traditionally done in RAG, right, and this type of approaches. So it's basically a way for so vector search was a way to navigate this embedded vector of this embedding representation of the textual files, which was working pretty smooth. So unfortunately, I can't show that demo because
Okay.
it's under NDA, but I will show another one. Yeah.
Okay, perfect. And you mentioned some customers and some types of solutions, you know, the robotics, the drones, etc. Are there other industries that you know can benefit from Lazy Dynamics solution as well too? Is it super adaptable, super scalable for other areas, or who would you consider your primary industries that you would go after in terms of business within Lazy Dynamics?
Right. So I think that the ideal customer is like the organizations that are building agents or autonomous systems for, as I said, mission critical tasks. So that face significant uncertainty, incomplete data, and need to make plans despite the noise. So,
Mhm.
and in fact, like not currently, we are onboarding co-development partners across, I would say, 4 primary sectors, and like we are basically in this stage where we're just trying to figure out, okay, what's the most lucrative at the moment. But it's so one is autonomous systems, yeah, particularly like drones or wheeled robotics. Then logistics, which is kind of interconnected with that,
Okay.
and predictive maintenance is basically to figure out, okay, when your robotic system or when your system will fail, and like what is the uncertainty around that failure. And there were quite some interest from finance industry, but yeah, we are not well. We'll see. So and but this industry is this, as I said, they share a common need. So they
Mhm.
require systems that can adapt to changing conditions while maintaining this reliability. Yeah.
Okay.
So that's what connects them all.
Which is, it's nice to have that super broad audience. And I think going back to the earlier conversation about agentic systems, I think it's really early days to figure out how and where they might be applied as well too. I think we've all seen the clever demos, but yeah, agentic system booking my holiday for me within my budget and getting my travel itinerary. Yeah, nice demo, right? But I'm really looking in all of these kind of demos under the hood at, where's the production application, where's the scalable application, outside of these, show and tell demos. And I think you guys are obviously addressing that area very much so. You seem to be at the cutting edge. Looking ahead beyond this, maybe what's the longer term vision for laser dynamics at this time, Albert? Or, kind of what else, what other areas could you get into perhaps too? I'm conscious that we'll show some demos, so I'm trying to just tee up the understanding of how this could be applied perhaps.
Sure. I think that just to linger a bit on the example you've provided with this, finding the trip like within my budget. I think it's a great application actually of this agentic system based on LLMs, right, or like VLA,
Mhm.
essentially transformers. But I wonder actually, are there precedents where people actually just trusted with their like whole heart, like to book any of those, right? Like
Yeah.
I'm not so. I've seen quite some people actually, well, onboarding these SDRs, right? The sales development robots, and yeah, like among my
Sales
friends so
development
far.
robots as SDRs. I like in MongoDB internally, we have SDRs, but they're sales development representatives. We haven't replaced them with robots yet. Have you? So you're seeing this?
Well, I do know that some people actually they've tried and they've hated it as well, right? So
Okay.
and the reason is the following again, right? So you're basically it's not a co-piloting system, it's like a really autopilot where you basically bet your business, where you bet your reputation on an LLM that can hallucinate. And I said, right, like for the spam, it can be perfect. I mean, like for creativity, yes, but
Yeah.
would you bet your well, let's say life, your business on that? I'm not so sure. So, and I don't know how our approach can address that yet. I really like we are really in the scope of more like physical world, like on yeah, something like really tangible, some
Mm,
signals that
mm.
we know what is the meaning of them. So and well, I must say that these agentic systems that are well now I don't want to what they're which are now which everyone is talking right now about. It's I think it's a it's a great tech for sure, but it's a bit unexplainable, kind of like it's a bit like you can't really figure out and trace back okay what really happened there, like, or
Yeah.
if
Yeah.
you can do it, it can be really costly. Like with our system, it's well usually like very much explainable, so we actually do know all the time what went wrong in the system, well, because it's model based approach, right? So it's also has it. I don't also to sell it as like this is the silver bullet for agentic system. No, it solves particular problems within agentic systems, but well, we'll see. It's still a long way. And when you ask like about the vision, I think the stretch goal is for sure to empower these planning abilities of agentic systems. So essentially to
Mhm,
become
mhm.
a brain for well autonomous systems, or let's say robotic applications. So I really want to envision the world where autonomous systems they can navigate complex and certain environments and yeah enable this adaptability, decision making capabilities, yeah, that were previously been impossible, so we can actually trust them. Yeah.
Okay. Okay. Well, I'm sure with that team that you've collected around you in Lazy Dynamics, I think I very much look forward to how things shape out. Adita, thank you very much for the comment as well. Appreciate that. If there's any other comments or questions actually for Albert as we go through, please do let us know in the comments and post them as well too. So I think, like always, I try to get the guests to showcase something and show us a little bit of a demo. So I think given the high level conversation that we've had now, Albert, I think it's probably about time to showcase some examples and a practical example, and showing us kind of what we've been talking about for the last 30 minutes or so.
Right. Okay. So let's start about it. I'll just make sure that everything runs.
No worries.
Yep, I think should be good. Okay, so the screen. Yes, entire screen. Okay, do you see my screen now?
Yes, that's it. It's coming through clear. We see lots of super interesting stuff, Albert. Here, what is it? What are we looking at?
Yeah. Okay. So this is actually a digital simulation of the drone environment. So like think of drone as an agent. And there are like 3 different tasks and scenarios for this drone. I'll start with what it's doing and then how we do it actually. So the first task, which, as you see here, so we have a drone which is basically continuously tasked with going from one point in the in this 3-dimensional space to another one. The thing about this drone is that it doesn't know anything about the obstacles that it will see in front of it.
Okay.
So the idea is that, okay, so the drone is tasked. So you say, okay, drone, you should go there. And then as long as it starts moving, it encounters different objects and it needs to adapt in real time to avoid those. So as you can imagine, drone doesn't have a luxury to stop its to pause its thinking, like what I do next. No, I mean, it doesn't work like that. So you really need to keep reacting on whatever environmental changes occur. So here we're just basically showing how drone sees its distances, like towards the So another kind of small example is that the drone here is essentially it knows that it needs to do this sort of a simple pattern, but what it doesn't know that it's raining outside. So obviously, when it's raining, this environmental condition changes for the drone, so it needs to adapt.
Okay.
And that's what we show here. So okay, there is sort of an adaptation going on, like as it's moving. So it tries to learn also, okay, that it now needs to operate with its actions or controls differently. So what does it have to do all with MongoDB? So and perhaps before going there, so there is actually another front end. So it's it's kind of real-time demo of the drone jumping from so the point where it needs to go generates randomly, and like as soon as it pops up, the drone kind of figures out this action space where how it needs to control its rotors to actually reach there. So you can see it's all kind of happens real time. So we kind of have the statistics over the engine forces. There's also a bit of code how it works, but let me get first into the what Ericsson, what MongoDB has anything to do with that. So so this is the demo that I just showed, right, where the drone needs just to follow this goal. And there are 3 components here. So the very first component is this front end, is like basically your simulation, or in the real world, it would be just a real drone. Infern, it's a server here which is running our engine. Like you can think of it as a brain kind of that decides what actions to send to the real world. So so it's kind of the inference engine, as we call it.
And that's the open source project that you gave me the link to earlier as well, too.
Right, that's
one
true.
here. Okay.
Yes. So this open source, I can say I can talk a bit on what's not open source, but later on. So and then there is MongoDB. So why it all matters, because all these things need to communicate to each other, and they need to communicate each other pretty fast, right? Because there is of course the server and the front end, or like the real world, where the communication needs to happen real time. And we would also prefer to have MongoDB communicating to the server also as real time as possible. So you don't want to have these lags and so forth. And that's essentially what's going on. So there are like 2 communication pipelines. So first is like from the server to MongoDB, and what it logs is current states, data logs, right? What was happening with thinking process, right? So how did we end up to use that particular sequence of actions in order to get to this place. We also store previous states, the parameters of the drones, right? Because it could happen that we don't have the full specification of the drone. For instance, we don't know its inertia. So it's something we need to learn, and we want to track over time how the drone was learning that. So this is very important. Also for basically analyzing if all of a sudden this drone flew to someone else's window, right? We want to know, okay, what actually went wrong there. And here what's important also is that sometimes why this rigid schema comes into play. Sometimes sensors fail, right? So it's something that the real world can surprise you with, right? So this can be like a failure in the sensor, in the rotor, or anything, and then it creates some non-values or like missing values, and that's something we also want to log right away. And another pipeline is from server to the front end. So yeah, as I see here is 30 events per second. Per second, and it's multi-dimensional observation, right? So we actually observe the drone observes different different data. So well, you can imagine like it's from camera, it can be one type of data, right? There is also let's say the position from IMU sensors. So it's really different and kind of scarce data we are working with. And yeah, so here what's going on is like real-time state estimation, prediction, and policy generation with MongoDB as a backend database. And it works pretty well. So
good. I'm glad to hear.
Yeah, and then just three things what we are using MongoDB for as well. So we've talked about different applications, some of which I'm not able to show, but so for real-time embedded systems, MongoDB turned out to be really good, like for high throughput, right, minimum latency, fast state updates. We also, as I said, like we're working with unstructured data or like badly structured data. When you're working with text, it's usually like that. So yeah, there was a good use of MongoDB vector search. That's also sort of a way for our agent to navigate the environment, okay, to find, okay, what the documents are relevant. And well, predictive maintenance, again, very similar to real-time embedded systems. So we want to identify these historical partners and react as soon as possible. So yeah, as just to conclude, right, different patterns and same database. So that's what we like MongoDB for.
Excellent. I couldn't have said it better myself. So no, I'm glad that you went through that. That's perfect. We did get a question in from Janani, and I hope I pronounced that correct. And she's asking, what kinds of path planning algorithms or approaches do you use when the agents are involved, and when the obstacles in the environment are unknown? Is that on yourselves in Lazy Dynamics, or is that on the client side when they use Lazy Dynamics?
No, that's a great question. Thanks a lot, Janani. So the thing is that I would have to go into a bit of the details of RX Infern. So it's on our side, first of all. So that's something we figure out for the client, or like for the user, essentially. So the way it works, and I really advise Janani to go into the open source, or like reaches out on GitHub. We can elaborate on that. So first of all, we we cast this planning problem as, sorry for the slang, but as a Bayesian inference problem. So we basically say as a the planning problem can be reframed as a probabilistic inference. So think of it this way, right? So when you do planning, you basically say to your agent or the drone that you want to be somewhere in some time. Now you can you can think it's kind of inverse problem, right? So you're trying to figure out, okay, what is the optimal path? However, why you can't solve it, for instance, with A star, which is like a very common algorithm for path planning, is that the environment which we are in is dynamic. there are many uncertainties around your sensors. There are many uncertainties about other obstacles. So we basically say to the agent that it needs to dream about this path first. And usually when the agent dream about this path, and like
Okay.
that's kind of what we do at the server, of
Mm-hmm.
course it has very optimistic agenda, right? So it thinks
Mm-hmm.
that, well, there will be no obstacles, or maybe there will be no, there will be no wind or something. So it tries to draw this very simplistic path, well, which goes ahead with this with accordance to least action principle. I will not go into there, but sorry to mention. And then um, when the drone starts to move according to its planned agenda,
Mm-hmm.
which we provide, which we gave you this plan, which you can execute, what starts to happen is that, well, there are like, some obstacles appear or some failures occur. And then it immediately tries to, well, circumvent it by replanning. And this replanning is usually, well, it's a very expensive task to
Mm-hmm.
do. So there is a whole way of doing it in our way. So we kind of developed this a smart way of planning. Let's put it this way.
Mm-hmm.
So we actually managed to replan in real time. And
Okay.
as for the as for the obstacles, of course the drone needs to sense something. So there should be some sort of a sensor that can see the obstacles. Otherwise, we are in trouble, right? It's like yeah.
Yes.
So there needs to be a camera or like some lidar or whatever that kind of can tell you, okay, how far you are from the obstacle.
Okay. And forgive me if you've already talked on this, but the that replanning, obviously that's all automatic. Is there some feedback loop back to, back to the customer who's using this that has occurred, or is it go and do the job, take into account of the paths, the obstacles, the environmental conditions, and finish the job?
Yeah. So okay. So this is where open source differs from pro version.
Okay.
So in open source version, you got to figure it out yourself how you're going to utilize all this replanning and planning and executing of the plan
Okay.
together. And
Okay.
I mean, we are helping with that, right? As much as we can, like on our GitHub examples or GitHub discussions.
Hmm.
But it's we also recognize that it's hard, and that's
Mm.
actually where the value proposition of Lazy Dynamics. So we automate that. So we
Okay. Okay.
basically tell you, okay, forget about all these worries, how to sort of create these loops or feedback loop, as you just mentioned, and we will just do that for you. So all you
Okay.
would have to do is to pre-specify, essentially to call just three functions, which is plan, act, and learn. So
Hmm.
and all the rest we are doing this magic for you. So yeah.
Okay. Oh, brilliant. Okay. So that's the pathway from open source to revenue as far as lazy dynamics are concerned then. So,
Right.
okay. Well, look, it makes a ton of sense. It's a well-worn pathway for services. MongoDB is open source essentially, but if you want all of the enterprise features, or if you want to use Atlas in the cloud, it's our software as a service platform. So that makes sense as well too. So it's a well-worn pathway. In Ireland, where I'm based, we have a company called Mana Aero that does drone deliveries, and it seems amazing. It seems fabulous what they do. It's for low value items, coffees and fast food and takeaways and things like that too. But I can imagine, given what you've discussed, the complexities that they must have to overcome, particularly the environmental stuff. As I said to you when we were jumped on the call, it's a really bad weather day here in Ireland. I can imagine that affects the flights and paths of those type of services. Are you seeing those services always seem to be kind of trial? Are you seeing those commercially used? I know there's been some nice case studies in Africa and elsewhere for medical supplies deliveries as well too. Is that any of your customers today?
So as for the robotics, right, concern, we've just started to onboard partners. So I
Hmm.
can't really disclose them. So we are, but they're like fast, like forward-thinking customers who recognize that, and then we are providing this sort of a solver for their drone dynamics. So and I do believe that in future that's how that mass delivery will operate, but there are quite many issues that needs to be addressed, right? So a lot of liability issues with that. Then there is obviously this sound noise, right? This
Mm.
pollution, right? This sound pollution. So this is something that I think this drone deliveries will face. I know there are companies which are actually trying to develop the drones such that they basically are almost silent. So
Mhm.
but that's
Mhm.
I think also a few years away. I remember when I was doing my masters in Japan, I think Rakuten was also just about to launch their drone delivery program. I mean, I've been
Okay.
there again. I've been there again like 3 weeks ago. It didn't materialize. So I think it's hard. It's hard, and as you said, there's a lot of uncertainty
Mm.
around those deliveries and like how also people approach these drones, right? So it's there are many issues that if you look at like from kind of surface perspective, seems like well, it's easy stuff like to figure out, but the devil is in the details.
Yeah, very much. I think, yeah, as you said, there's a lot of these companies just about to launch commercially, and it's always just about to launch. You mentioned, I think, at the intro as well, probably the more understandable scenario of, warehouse, and there's robots and there's automated systems in warehouse that do things. We see all from time to time the large retailers, automated warehouse, etc. Obviously, the drone example is one that catches the attention, but I would imagine the scale of the warehousing robots automation is something that's an enormous challenge to tackle as well too,
Oh
with
yeah, yeah.
what Lazy
I
Dynamics can offer.
Yeah, I think I can also share that. I think we have a bit of time, right? So
Yeah,
if that's
perfect.
okay.
And Janani came back and she said, she learned some probabilistic path planning in class, and why she asked the question. So she thanks you for your insights there, Albert.
Okay,
Thank you,
okay,
Janani,
okay.
for the
So
question.
yeah, thanks a lot. Yeah, yeah. I love these questions for from people who already know the answer, right? So, but yeah, okay, good, good. No, I just invite her to check us out. So I think she would
Yeah,
find it interesting. Yeah.
perfect.
So yeah, there's a small, just another example. I think you just mentioned this warehouse, and I think
Yep.
this is also a perfect kind of situation where our solution is very handy.
Hmm.
So
Hmm.
here you have this kind of 2D, like a bird's eye view of a warehouse. So you have these four agents that are tasked to go from one location to another,
Hmm.
and locations are represented as stars.
Hmm.
These small agents, they also have sort of this, this dashed circle around it, which is basically their sensor, like
Hmm.
where they can locate the obstacle. And the task by itself, if it was just a static environment, it's not that hard. Like it's really not that
Sure.
hard. I mean, especially it's static environment, only robots are there. But imagine it's not only agents, like I mean robots, but there are also humans.
Hmm.
And not to say that only humans make mistakes. Like also agentic systems, like robots, also can block the aisle or do something nesting like that will disrupt the plant. But here we actually deal with a very, let's say, hostile environment, like
Mm.
basically an environment that changes all the time. So when the agent tries to execute its idealistic plan, right? Like it tries to sort of find to dream about how it would go. Uh, the environment always pushes back. It doesn't let the agents to materialize. So they actually need to navigate seamlessly. Okay, how do I avoid this? How do I avoid that as
Mhm.
they go? Because again, we can't stop some of the processes which are ongoing. So the task was here to okay, we define the requirements for the agent. That's actually example, I think also in our open source, which is, I think like 15 lines of code just to define
Right.
this model.
Okay.
And the task is the following. So respect the speed, respect the distances, and go from one location to another. And then, the agents, they figure out how to do that. Yeah.
Okay. Okay. Yeah, and incredible. I suppose under the hood, we don't generally think of these things to this level of detail. But obviously, of course, and as you mentioned, the driving example originally, the environment is ever changing, and you just can't, as you say, I love the term that you used, dream about the perfect path, but that never probably ever occurs, right?
Yeah, absolutely. I mean, like for us humans, right? I mean, just saying, you're like, you think that something will occur, and like it just happens in a completely different way. And nevertheless, yeah, we managed to adapt. So, I mean, I haven't mentioned that, but like actually our professor, right? Like he's been always fascinated about how biological systems adapt, and
Mm-hmm.
like many of things that we've implemented also actually try to draw some of the inspiration from yeah,
Sure.
what he's been thinking about. So yeah, how we human adapt reactively as the environment changes. So that's a interesting topic for sure.
Definitely, definitely. No, this has been fascinating. I suppose, and look, and obviously that the fact that you've done a doctorate, etc., as well, too, you're an avid learner, Albert. But this space, as look, for those that who don't know anything about this space, you think AI is only 2.5 years old, right? For anyone who does, it's been machine learning and artificial intelligence for many, many decades. How do you keep up to date with the changes in this space, and where do you go to learn and keep ahead of things for Lazy Dynamics as the CEO?
Yeah, that's a great question, Shane. I should say that I think that what's really important is to build the community around you that
Hmm.
do different things. Specifically, yeah, I have friends who are thinking that Transformers is this best thing since sliced bread, right? So who are really like very like venturing into that, and I respect that. I think that even though yeah, I disagree with them, I'm trying to keep up with that. So I think that for us, what's important is to really build up the community around things which are complementary or competitive to us. So just to stay kind of relevant, to see what's going on. I think there is also a lot to learn from these things, right? So you can have all these other agentic systems, right? There is a lot to learn there. So from
Mm,
optimization perspectives and so forth. And so this is basically the way we stay relevant. And I think what's most important is for our companies that we are really well venturing in. So we do. It's very important to believe in what you are doing, right? So
of
sorry to
course.
sound this cliche kind of stuff, but that's the reality. So we do think that our approach is the best one, is the right one, and like for
Mm.
specific problems, it will be well, it will draw others obsolete. And I think that this is very important. So yeah, I guess these two things: community and of course believing in what you are doing. Yeah.
Yeah, I love the community aspect of that. And I suppose obviously you're getting feedback from the early customers, the early adopters of Lazy Dynamics as well too, and you're enabling them and growing with them as well, which is amazing to see. It is a yeah, it's a fascinating area that you've gone into, and I think obviously timing is everything too, Albert, right? So you were doing work in these spaces, throughout for a vast number of years, obviously, and then saw the commercial prospect of what you've been doing and gathered that team around you.
Yeah, that's right. That's right. I think yeah, I should have mentioned the partners and customers because these are the well the real asset who kind of makes this reality check for the product, right? So because again, like as founders from academia, and I see it a lot, right? Like everyone who is trying to launch out of the lab, they're trying to basically they have an amazing technology and they're like trying to find the fit for it.
Mm,
And we were like just like that. So we thought, yeah, we have this amazing technology, but I mean, truth to be told, no one cares, right? So it's about the right problem that your technology can solve. So this is hard. And like as soon as you realize that, you find your customers and you actually get uh, very valuable feedback actually that
mm, mm.
shapes your product, shapes your technology in the right way.
Yeah, no, it's great, and I suppose given the background that you all have with all your PhDs behind you in all the different areas, I used to work with a lot of startups, and what we find a lot of the time is startups are building products, but they're afraid to go out there into the open and get customers because it's a real world validation of their system. Whereas you seem to be very clear on how Lazy Dynamics can help these customers already, and the environments and the applications to which they can be beneficial, right?
Right. Yeah, that's a great conclusion. Yeah, I think
Yeah, well, like
how it is.
for a company 18 months or so old, I think you've come on in leaps and bounds, Albert, and it's great to share your story and the journey that you've had, and give us kind of the glimpse of the insights into kind of the innovative world that you occupy in Lazy Dynamics. Before we wrap up, and I didn't see any other questions come in, so obviously, as I said to you on our prep, usually that means you've been very clear in your mission and what you set out to explain here. So that's great. Any last words for our audience, maybe from the point of view of, going out there and founding a company, or what's happening in the agentic world, or how to keep up or how to learn?
Yeah, I think we've touched upon all of these topics. I think that well, just one thing I would love to ask people for, I guess, is just to check out Infern, check out Lazy Dynamics. Infern is completely open source, and I'm sure that every expert in their own field would be able to relate to some of the problems we highlight on our open source website, and well, just reach out for anything, like just be it open source question or like the possibility for a potential project together. So we are open for any sort of collaboration. Yeah, that's basically it.
Excellent. Well, listen, I think that's a good call out to wrap up our podcast here. Albert, it's been a pleasure having you on board and sharing. I will certainly keep an eye on what Lazy Dynamics are doing. And, whenever the next stage comes around, or whenever the next demos that you have, I'd love to get you back on the show as well to explain. But I think for now, obviously, as you said, go to Oryx Infer, and also, as you see on the screen there at the moment, lazydynamics.com to learn more. But from now, for me, Shane McAllister, thank you so much. Albert, it's been a pleasure to have you on board, and all the best with you and the team at Lazy Dynamics for the future. We wish you every success.
Yeah, thanks, Shane. Thanks.
Excellent. And for all our viewers, thank you very much for joining us. And do keep up, as I said in the introductions, if you like and subscribe to the MongoDB YouTube channel, you'll get alerts for similar live streams such as this. And also follow us on LinkedIn to get similar event notifications there too. I stream most Tuesdays at roughly this time with lots of amazing guests such as Albert, so do join in. But from both of us now, thank you all for tuning in. It's been a pleasure to have you. And Albert, thank you once again. It's been great. Take care, everyone. Good luck. Bye-bye.